Welcome back, everyone. Today we're going to cover how to make and read a box and whisker plot. The first thing I want to talk about is what a box and whisker plot is, what it does, and what it looks like. So suppose we are given a set of data right here, basically just scattered about on a number line in no particular fashion, and I want to represent how this data is spread out. You might notice by looking at these dots down here that some of them are quite spread out, others are clustered up, and some of them are kind of in between the clusters and the spread out phase. So if I were to be able to express this data visually in such a way that I was able to see which parts of it were spread out and which parts of it were compressed, that might be useful to me in figuring out whether something is popular or not when I'm looking at a data set. So the way a box and whisker plot works is that it takes the data points that are all down there and it breaks them up into 4 equal segments that each contain the same number of dots. Now, if you go through and you count all these dots, I think there's about 50 dots there. And if you break it up into sets of 12, we get boxes that look like this size, as long as these dots are posted on a number line. So I can't move these dots around at all. They're posted on a number line at a specific value. So if I have to draw my boxes around 12 dots, the boxes look like this. I think some of these boxes have 13 dots in them, but you get the idea. About 12 dots per box. And instead of just keeping it nice and simple like that, whoever decided to make a box and whisker plot decided to not make it just boxes, but a box and a whisker. So this middle box right here contains 2 of the quadrants, so 50% of the data right there. This box has 25%, that box has 25%. And the final quarters that are on the outside are represented with these whiskers, representing how spread out the data is. And when you look at one of these, you can see, well, if this has 25% of the data and this also has 25% of the data, then this data right here is far more spread out than this data right here. The main thing that you need to look at when you try to read one of these or when you make one of these is that each of the pieces, the whisker, this box, and this box, and this whisker, all contain the same number of data points. I wanted to show you a couple other box and whisker plots. Math textbooks, for whatever reason, they tend to make them horizontal, go left to right. In the real world, when you see a box and whisker plot, they tend to be vertical. So I just wanted to show you what a vertical box and whisker plot looks like and how differently they might be shaped. In this picture, you can see 3 different distributions. One where all the data is uniform. There's the same number of points everywhere on the number line. It's nice and steady. So you can see this box and whisker plot. Each of the whisker and each box is the same length. Here's one where there's a lot of data in the middle, so you can see that those 2 boxes are much shorter in length. They've been compressed, showing a high density of data points, and way out on the edge there's even an outlier here, and those whiskers are stretched way out to represent that there's not very much data way out on the edges. The third one is one that's not symmetric. So you can see that this part of the graph right here is pretty compressed, representing a high density of data points, whereas this part of the graph is far stretched out, representing a low number of data points on that edge of the graph. And if you get good at reading these types of box and whisker plots, you can really determine a lot of information from a single picture very quickly. That's the advantage of using a box and whisker plot. So the key understanding in this whole section today is that each quartile of the box and whisker plot is going to contain 25% of the data points. And what I mean by quartile is the whisker is a quartile, this box is a quartile, this box is a quartile, and this box is a quartile, because it covers 1/4 of the information. There's really no distinction between the whiskers and the boxes in terms of their size. They just each contain 25% of the data. Before we go into how to make and how to read a box and whisker plot a little bit more in depth, I want you to pause the video right here and draw this drawing. I'm going to have you label it with all these vocab words, but I thought it might be easier for you to just pause the video right here, make this template, and then we can add the vocab words afterwards. So go ahead and pause the video here. And go ahead and write down all the appropriate or all the vocab words where they are labeled here. Hopefully a lot of these words make a lot of sense to you. There's a median right here, a lower quartile and upper quartile. So that means that the middle of the data at the median, remember a median is the middle of a data set. We have a lower quartile representing the the border between the lowest 25% and the next group of 25%. So that border is called the lower quartile. It's also abbreviated as Q1. Same with the median is Q2. That stands for quartile 2. And then this upper quartile, the top of the inner quartile range, this whole thing, is called Q3 oftentimes. Then we can use the words minimum or maximum, but lower extreme and upper extreme are just a little bit more common when we talk about box and whisker plots. And also there's an informal recognition that we can also call this Q0 and we can call this Q4. That way we have Q0 through Q4. So when we start doing our first example, we'll go through what each one of these means. But basically, your inner quartile range is the middle 50%. We've got a maximum, we've got a minimum, we've got a median, so just finding the middle of a data set. And the only new things that we need to deal with are this lower quartile and upper quartile. You know how to find a median. The lower quartile is just the median of this half, and the upper quartile is just the median of this half. So it's not too difficult. The only complicating factor is occasionally you'll see a box and whisker plot with a little guy right there. And what it is, it's a point that's like way out of bounds. So basically way too big or way too small for the rest of the graph. And we call this little point right here an outlier. An informal definition of an outlier is just a point that's way bigger or way smaller than most of the other data. In terms of a math definition, there's a few, actual ways to calculate an outlier, whether something is or whether something is not an outlier. But most of the time, you'll see this definition. It has to be 1.5 times larger or above, like 1.5 times the IQR. So this distance between that line and that line, take that distance, multiply it by 1.5, and then tack that on to Q3. So Q3 is right here. If we took that distance times 1.5 and went way out here, that anything that's outside of that range would be considered an outlier. That's a really complicated description of what an outlier is. The best way to describe it is you'll know it when you see it. It's way too big or way too small to really fit within the data set. And if I wanted to do just one quick example of an outlier, say we had an inner quartile range of 10. So the distance between here and here was 10. And there was a data point that was 15 points above quartile 3. Well, 1.5 times 10 is 15. And if it was more than 15 points above Q3, so more than 15 units over here, then that point would be an outlier. And same with the bottom end, by the way. If it's more than 1.5 times the inner quartile range off to the left, it is also an outlier. So how do you make a box and whisker plot? Basically, your main task is to chop the data into 4 equal parts. So the first thing you want to do is basically we're going to find a median, and then we're going to find the median of each half. So the first thing you want to do is put your data in order, then chop the data in half. You're going to find the median. You can label that as a Q2. You'll probably be asked for that within the problem. Then the remaining halves that you just chopped the data into, you're going to chop each of those halves in half. So you're going to find the median of the remaining 2 halves. And if it happened to be that the median that you found in step number 2 was a number in the data set, you're going to exclude that number when you go ahead and find the other 2 medians. It sounds complicated. It's a lot easier than it sounds when you write it out. Then you're going to actually go and make the box and whisker plot. We're trying to make this shape. So what we're going to do is we're going to take those Q1, Q2, and Q3, and we're going to draw this bar, and this bar. We're going to draw a box around that. And then basically we're going to tack on our minimum value and our maximum value and draw a little whisker out to each of those. Let's look at our first example. Right here, I've got a data set. The first thing I want to do is put that data set in order. That way I can chop it in half and go find the median. In this case, it was an even number of data points, so I have to take the average of the middle 2 values. They're both 31, so if you add 31 plus 31 and divide by 2, you get 31. So our median, our Q2, is 31. Our center line is going to be 31. Then since I didn't use the number 31, I'm actually finding an average of those 2. I'm going to go find the median of this remaining half right here. There are 5 items over here. So if I find the middle of that, I get 33, and if I find the middle of these 5 items, I get 27, meaning that this should be Q1 right there. Q1 should be 27, and Q3 should be 33. Then we're going to draw lines on the number line in those places, and then we're going to draw a box around it, and then we're going to grab the biggest number, 49, plot that, the smallest number, number 11, and plot that, and add whiskers out to the side, just like so. That's our box and whisker plot done. I want to do one more that has some slight complications with it. Our next example has 13 data points right here, and I was nice enough to give it to us in order. So finding the middle is pretty easy. We just go find the middle. That's going to be our median. Then, since I used that point, now I'm not allowed to use it when I go find the median of the other half. So I have to consider only the six data points on the low end side and only the 6 on the upper end side. So if I find the middle of those two, Q1 is 3.5, the average of 3 and 4, and Q3 is the average of 15 and 16. Go ahead and draw those in, draw a box around it, and then we're going to do a minimum value of 1 and a maximum value of 35. And then you'll notice that 35 is an awful lot bigger than the rest of the numbers, so let's just do a off-the-cuff calculation just to see if we have to consider 35 as an outlier. So the question is that an outlier or not? Is it far out enough? So we're going to use this formula. Quartile 3 plus 1.5 times the length of the inner quartile range. So the inner quartile range is the length of the box right here. So if I go 15.5 minus 3.5 right there, I'll get the length of the box. So if we plug in all those numbers, our quartile 3 was 15.5. Then we're going to go 1.5 times all of this. Go ahead and throw some more calculations down, get an actual number, and this says 33.5. Now, if 35 is outside or larger than 33.5, then we have to consider it an outlier. And 35 is bigger than 33.5, so we have to consider that last point an outlier. And to signify this on our graphs, what we do is we put an asterisk and then we drew a little dashed line, and that's going to be our real maximum right there. This one we're kind of tossing out and not allowing it to affect the shape of the overall graph. And that's an example of a pretty complicated box and whisker plot. The only other thing you have to worry about today is being able to read one of these. So I've got actually, I think, 7 or 8 questions to go along with this one little graph, and there's a lot of different types of questions you can be asked. What's the median value here? Well, we go to the middle. That's 21. That's pretty easy. What's the upper quartile? Well, that would be this bar right here, 26. What's the lower quartile? It would be this bar right here, 16. What's the range? Not inner quartile range, what is the range? So what's the length of the whole thing? So we'd go 38 minus 6 to get that, to get 32. The inner quartile range is a specific vocab word just for today. It's the length of the box right here. So we're going to go 26 minus 16. That represents the distance that covers the middle 50% of the data. And should 38 be considered an outlier? So again, we're going to go like Q3 plus 1.5 times the IQR. And if we get a number that's larger than 38, then 38 should not be considered an outlier. If we get a number that is smaller than 38, then 38 should be considered an outlier. If we do that calculation, we get 41. So we take 26 plus 1.5 times the IQR, which is 10. And we get 41. 41 is bigger than 38, so 38 falls within that range, so we're okay. There's also some questions that can be asked about how far the data is spread out. And remember, each part of this graph covers 25% of the data. So this is 25%, this is 25%, this is 25%, and this is 25%. So if you can get asked questions like this, what percent of the data are greater than 26? So that would be 26 and up. That covers one segment of the box and whisker plot, which is 25%. Less than 21 would be here and downwards, so that covers 2 segments of the box and whisker plot, so we say 50%. And greater than 16, well, that's this one, and it would be this way, so that's 1, 2, 3 sections of the box and whisker plot, so we'd say 75%. That's what you need to know for today. I'll see you next time.